Okay, so this is the first problem we've encountered with our robot. And by we, I mean me. Anyway, so the original design here, this large gear was inside and the small gear was also inside. I'm in the process of changing it around. But anyway, so coming off of our drive motor, we have a large gear and then two smaller gears, right, to drive the wheels. One thing I noticed early on that I don't like is that we don't really need speed to complete any of this obstacle. So this gearing is more indicative of speed, and I'm more concerned about torque. So I did want to change to a more torque oriented gearing like I have here, which is small to big. But the other more immediate problem is that when your robot is going up the ramp we have set up in class, this large gear in the center doesn't clear the tip over point, and it jams up right there, which throws your robot out of alignment and it's going to mess up your code. So you think, okay, we're going to switch remember this gear was inside of here, I just moved it. We're just going to switch the gearing to like what I have here. Well, if you try to put this inside of the frame, it's not going to fit. So you do have to move it to the outside so these gears can clear everything. And once I have this set up, everything should be working beautifully. But that's the first problem in our build process.
Okay, so moving on to our code here. We have first, hopefully you can see my cursor. Anyway, we're just including our necessary libraries and also setting up our display. Simple, and then I am setting up a few variables here, and later we will see why we need these. Naming motors, right motor, left motor, obviously. And now into the meat and potatoes of it. So those are just the pins of our motors. Okay, our first real command here. We are going to start our LCD and display button count. And now we're going to continue displaying the variable button count because that is very important. That is going to let us know how many times we encounter an obstacle. And every time our button is pressed, it's going to go low, and that is going to add 1 to our button count. The reason for this delay is so that when our robot encounters an obstacle and it hits a wall, the button's pressed in. Need a little delay to make sure that it doesn't keep adding 1, super fast. And then this, we're just displaying this in our serial port so that I can see how the code is working as it works without running the robot. Okay, so here's the really important part. So our first while loop. When our button count equals 0, which is when we start the robot, we're going to drive forward. So we're going to write to both motors 20, and the way the motors work is they go from 0 to 180, 90 being the center, which would be still. So 20 is going to drive them forward. Right? Then, if our button, and this is still inside the while loop, if our button is pressed and it's going to go low, we want to add 1 to our button count. Alright? And this is a really important part. We're going to start a timer. Okay? And this is going to come up later in the code. So this is again just displaying the button count. Okay, so our robot has driven forward, it's encountered an obstacle. We've added 1 to the button count. So now our button count equals 1. So if our button count equals 1, we want the motor to quickly reverse direction for half a second. Whoop. So it's going to reverse direction for 500 milliseconds, half a second. That's just to give it a little bit of space before it does the next command, which is to make a right turn. So the motors are spinning in opposite directions. That's going to make our robot turn. And if it turns for 940 milliseconds, we're going to turn 90 degrees. So it does that, it turns, our button count is still 1. Alright? And now, say there's another obstacle. It's going to hit something else because on like the first turn, it's our robot is always going to make a right turn first. But sometimes it might need to make a left. So the way it makes a left is by making first a right, then it's going to hit another wall, encounter an obstacle, and then it's going to turn 180 degrees. So if it makes a right and it hits the wall, because that's a dead end, we want it to add 1 right here. So again, if the button's pressed, it's going to add 1. Alright, and when it adds 1, we're going to take the time passed and we're going to subtract the current time from it, and that is going to give us the time between our 2 button presses. So this button press and up here this button press right here. So what we do with the time between those 2 button presses is we want our robot to drive forward, and if it encounters an obstacle, we want it to make a right turn. If it encounters an obstacle again, we want it to then make a 180 and go left. But if we just added 1 every time the robot hit a wall, then it would never go straight again. So what I have here is this max time R. That is the amount of time it takes the robot to make a right turn, which is just the time that I've recorded, and we have that up here. So that is the time it takes the robot to make a right turn. So if the time between button presses is longer than the time it takes the robot to make a right turn, then we know that it didn't hit a dead end when it turned right. So we want to reset the button count to 0, which is going to bring us back up to where our robot is just driving straight. So now it's going to drive straight. But if that time is not greater than our max time are, then it is going to add, it's going to add 1 to our button count, and our button count is going to move up to 2. This, again, is just displaying our button count. It's very important to have this readout because it tells you exactly what's going wrong, if anything's going wrong. So now, so we've gone straight, we've encountered an obstacle straight, we made a right turn, immediately encountered another obstacle. Now the robot's going to turn 180 degrees. First it's going to reverse for half a second, and then it's going to turn 180 degrees. So motors spin in opposite directions for 2 seconds. And excuse me. Now it's gonna, once it makes that 180 degree turn, it's gonna start driving straight. And again, after it starts driving straight, when it hits a wall, we're gonna add 1, and we're gonna again measure between the last button press and the current button press, because if that time is longer than the 4 seconds it takes for the robot to turn at 180 degrees and immediately encounter an obstacle, then we know it went straight unimpeded, and that is going to reset our button count to 0, so the robot can just act normal, make a right turn if it has to. Otherwise, if the button count if it adds 1 to the button count, that's going to make our button count 3, which brings us down here. So the situation where the button count is going to get to 3 is if the robot hits something immediately in front of it, makes a right turn, hits something immediately to the right, turns 180 degrees, and hits something immediately to the left. That's 3 sides, so we know we're at a dead end. In that case, I just want the motor to back up. I just want the robot to back up so it's not touching anything. So it's going to back up for half a second. And then, while our count is 3, meaning it's hit 3 walls, we're going to write 90, which is that center point. It's going to make the motor stop. And I want it to display a nice little message. And on the LCD, it's going to say done. And you will see that in the video of operation, which is next.